So I'm going to give you guys a little table first to give you an idea. Remember that there's three kinds of graphs you're dealing with, right? You've got linear, you've got quadratic, and you got exponential. So what happens is that with linear, the equation is y equals mx plus c. With quadratic, it's y equals ax squared plus bx plus c. And exponential, y equals a rx plus c. I think the common mistake that I've seen people do is like when it comes to straight line graphs, they just take quadratic equation, put it together, or exponential graph, they put quadratic. Yeah, so the best way to actually do this is for each of these little tables here, what you can do is look at the differences of the y value itself. So for example, if I have 1, 2, 3, and say this was 7, 10, 13, and then here I've got 1, 2, 3. Let's say I've got something like 7, 10, and 15, and then here I'm going to have 1, 2, 3, and I've got 7, 9, and wait, sorry, I'm just trying to do this in my head. 2, 4, 2, 4, 8, 2, 4, so 13. Eight, 13, 13, 13, 8, 21. Okay, so for you to figure out whether something is linear, you always take the y values and you find out the differences between them. So if it's linear, so you know 10 minus 7 is 3, 13 minus 10, it's 3. So if the first difference is the same, then it's linear. All right? But so that's how you know straight away it's a linear, if the first difference of those y values is going up by a constant number. If you look at a quadratic, what you got to do is you got to look at the differences. You got 3, and then you got 5. But what generally happens is the second difference ends up being the same number. So what I'm doing here is to find 3, I'm going 10 minus 7, 15 minus 10 is 5, 22 minus 15 is 7. So straight away I can see this is not linear because the first difference, they're all different numbers. But then if I look at the second difference is the same. And because second difference is same, I can say that it's a quadratic. And here's another hint. If it's a quadratic, you can actually say the a value is the second difference, whatever that value is, divided by 2. That's how you kind of know that the difference between the first, if it's the first difference is same, then it's linear. If the second difference is the same, then it's quadratic. But for exponential, you look at the differences. So you've got 2, 4, and 8. So with exponentials, what you should notice is the pattern of these numbers here. All right, right now it's going 2, 4, 8. And if this pattern was to continue, the next number here would be 16. And then that would be 37 there, for example. So if you try to find the second difference for this, because we know the first difference is not the same, so it's not linear. If you look at the second difference for this is going to be 2, 4, 8. So the second difference is not the same, so that's how we know it's not a quadratic. So we know this is not a quadratic or a linear, so the only other graph that you know is exponential. But also what you should notice is if you look at the red numbers, they're actually doubling. So in other words, this is what's happening here. It's actually going times 2, times 2, times 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Now this 2 right here, there's a relationship for it, and that is ratio. that's the ratio it's actually increasing by. So r is actually equal to 2 in this case. Okay, so what I want to focus today on is just exponential questions. So that question that you guys had, a little practice question, the numbers was 0, 1, 2, right?
Yeah.
Yep, but before that, I'm actually going to take you guys through this question here, and we're going to try and figure out what the equation is. So to do that, let me just copy all of this. Control C. Do you have to mow your lawn right now? Oh. So what we had was y equals to arx plus c. So if you want to come up with an equation for this particular table, right? You've already figured out what r is. You know how you kind of look at the first difference and then see how much it's increasing by? So you've got r. So what you can do is you can write this equation as y equals a times 2 to the power of x plus c. Now, the next step is take a couple of these points and substitute them in to create like a simultaneous equations. So what I'm going to do is I'm going to first take 1, 7. All right, I'm going to take 1, 7, and I'm going to substitute 1, 7 where x and y is. So this equation is going to look like this. 7 equals a times 2 to the power of 1 plus c. Then I'm going to take a second point, which is going to be, whoa, why is my highlighter not working? Which is going to be 2, 9. And once again, that's x and y. So this is 2, 9 right here. So I can go 9 equals a, 2 to the power of 2 plus c. Okay? So I'm hoping you guys can see I've actually created a set of simultaneous equations. Because this equation here, I could rewrite this as 9 equals 2 squared is 4. So it becomes 4a plus c. This equation here is going to become 7 equals 2 times a plus c, because 2 to the power of 1 is just 2. So then what I can do is I can go the top equation minus the bottom equation. So I've got 9 minus 7, 4a minus 2a, c minus c. So c minus c, that's going to become 0. 9 minus 7 is 2. 4a minus 2a is 2a. Which means I could actually say a is equal to 1. Because if 2a equals to 2, then a is equal to 2 divided by 2, which means a is equal to 1. Okay? So what I've figured out now is I've actually figured out that y equals a is equal to 1. I don't really need to write it. 2 to the power of x plus c. Is that alright? I still need to figure out what the c value is. So what I'm going to do is I'm going to use that point 1, 7, which is that point from the table. So I've got x and I've got y. So 7 equals 2 to the power of 1 plus c. 7 equals 2 plus c. C equals 7 minus 2 and c equals to 5. So this equation here is y equals 2x, 2 to the power of x plus 5. Give me one more second.
It's like it's negative values.
Yeah. Okay. So we got plus 6, plus 12, plus 24, plus 48. So we can kind of see that everything is getting doubled. So r is equal to 2. So we can write y equals a 2 to the power of x plus c. Then take 2 points. So I'm going to take point 1, 7. And when I do that, I get 7 equals a times 2 to the power of 1 plus c. And then I'm going to take the point 2, 13, which is 13 equals a times 2 squared plus c. I'm going to rewrite this equation at the bottom here as 13 equals, now 2 squared is 4, so 4a plus c. And I'm going to rewrite this equation at the bottom here, where it's going to be 7 equals 2a plus c. Then I want to subtract it, so I want to get rid of the c's. So subtract, subtract, subtract. 13 take away 7 is 6. 4a take away 2a is 2a. C minus c is 0. So we can say that a is equal to 6 divided by 2, which is equal to 3. So I've got my equation here as y equals 3 times 2 to the power of x plus c. And I'm going to use the point 1, 7 again. So 7 equals 3 times 2 to the power of 1 plus c. 7 equals 6 plus c. C is equal to 1. Therefore, equation is 3 times 2x plus 1. Okay? Now,
will there always be an exponential question in the
I know in the last, like back in 2014-15, there wasn't hardly any, but now there's almost one. Because people have been asking for it all the time. Can you please make sure that exponential comes in?
Why?
Let's see if we can do the exponential one. Is just so friggin' tricky. Okay, try this one here. And I think if you get this one, then I think you're ready to answer that one that we gave in the practice papers.
Oopsie, looks like I'm not ready.
Okay, have a look. So the first thing I'm gonna do is
5. Why is it 5? Why is A 5?
Hey, shush.
Oh, I'm.
Hey,
Okay.
Shush. I'm trying to do this. So you got 4.25 minus 5.5, which is negative 1.25. Is that right?
Yeah.
And then after that, you're getting negative 0.625. And then what is it after that? Because I can't do it in my head. 3.125. Is that it?
What?
Yeah, 3.125, right?
Yeah.
Okay. So what you should see is these numbers here. You're like, they are actually, if you look at just the numbers, they're actually halving. All right. The negative is a ruse. It's like people think it's actually negative half, but it's actually just half. The easiest way to do this, to confirm your suspicions, is get your calculator out and do this. So see how you got that I'm looking at that second difference and the first difference. You just put one of them on top of each other. So you got negative 0.625 divided by negative 1.25 equals 0.5. And then you try it again for the next one. You're going to get negative 0.3125 negative 0.3125 divided by negative 0.625. So notice how both of those numbers are 0.5. That's how you know that the ratio is actually 0.5. So I can then go back here and say that ratio equals to 0.5. So y is equal to a 0.5x plus c. Then take my 2 points. I'm going to use the first one, which is 1 and 5.5. 5.5 equals a times 0.5 to the power of 1 plus c, which is 5.5 equals 0.5a plus c. Then the second one I'm going to do is 2 and 4.25. So I've got 4.25 equals a times 0.5 squared plus c, which could be written as 4.25 equals 0.25a plus c. So I'm going to write this equation at the top here. So it's going to be 5.5 equals 0.5a plus c. And I'm going to write the second equation below it, which is 4.25 equals 0.25a plus c. And then I subtract both of them. So subtract this, subtract this, subtract this. 5.5 minus 4.25 is 1.25. Equals 0.5 minus 0.25 is 0.25a. C minus c is 0. So then a is equal to 1.25 divided by 0.25. A is equal to 5. So once you get a equals to 5, you've got y is equal to 5 times 0.5x plus c. Use the points 1 and 5.5. You've got 5.5 equals 5 times 0.51 plus c. And then you end up with 5 times 0.5 is 2.5 plus c. So c is equal to 5.5 minus 2.5, which is 3. So the final equation is 5 times 0.5x plus 3. This part real quickly, alright, because it's just, I'm looking at the time right now. So you got x and y, right? Your numbers are 0, 1, 2, and so on.
Yep.
I'm going to give you guys a bit of a little cheap trick here. 100,
66.666.
and then
44.
44.
22. 29.63.
Yeah, whatever. 29.63. Now, if I look at the difference between these ones, right? So this one is 33.33. This one is 22.22. This one I've got no idea. Did you do the difference? It was 14.81, wasn't it?
Yep.
So 14.81, just roughly, right? Now watch what happens when I actually take this to the calculator and work out the ratio. So I actually take that second number, which is 22.22, and I divide it by 33.33. I actually get that number there. Even if I convert it to a fraction, I get f to d, which is fraction, decimal to fraction is 2/3. So if you want to do that, you press this button here. Okay? Now I can double check it by going 14.81 divided by 22.22. That's roughly that. So that's because the number has been rounded up. But you know, it's going like this, but in reality it's actually 2/3, but it's just rounded up. So that means your r is equal to 2/3. Give me a second, I'll actually wait till these guys all leave. See, now this one, you've actually got r is equal to 2/3, right? So I'd actually go back and go, I'll put my equation as is. So y is equal to a times 2/3 x plus c. Rather than using, I actually will end up using this point here and that point there, because that's a lot easier when I put 2 to the power of 2 over 3 as to the power of 0 or 1. Did you finish it? Yeah. Okay, so the first point I'm going to use is 0, 100, which means I have 100 equals a 2/3 to the power of 0 plus c. Now remember, any number to the power of 0 is 1, so I can say 100 is equal to a plus c, because 2/3 to the power of 0 becomes 1. The next point I'm going to use is 1 and 66.66. So I've got 66.66 equals a 2/3 to the power of 1 plus c. So this right here is going to become 66.66 equals 2/3 a plus c. So what I can then do now is write this equation here, this one here, and subtract them out. So I've got 100 equals a plus c, 66.66 equals 2/3 of a plus c, which means I can go 100, take away all of these things, because I got to subtract the bottom equation. So I got 100 take away 66.66, that's 33.33. Now 1a minus 2/3 of a is going to be 1/3 of a, and then c minus c is 0. So here a is equal to 33.33 times 3. Now remember, these numbers are actually rounded up. Alright, so really this number here should have been 33 1/3, because it's a recurring number. So if you do 33 1/3 times 3, you actually end up with a is equal to 100. And if a equals to 100, see this equation here?
Yeah.
From here, we can actually see 100 equals 100 plus c, therefore c is equal to 0. So now your equation ends up being y is equal to 100 times 2/3 to the power of x. So the reason why we can't just do that is because if I do this, where I go 100 times 2 over 3 to the power of x, see, this is what the graph actually looks like. There is an asymptote right here where the x-axis is. So this red line is never actually going to touch the x-axis. And if you look at your table, you know, at 12 it's at 0.77 and so on. Like, look, even if I do this, if I actually create a table, right, even if I use, like, say something like Desmos, what happens is, what was the numbers going from? 0, right? So 0,
1.
1. Oh, what have I got? Oh, sorry, I made a mistake just in my equation.
Yeah.
That x should have been outside. Better. So see how that is actually rounding, it's actually rounded up in your actual workbook. And if I keep going, that number is never going to actually reach 0. See how that around here, that value is always, I'm actually going to show you guys here, right there. That's always going to go close to 0, but it will never actually hit 0, because that's what you call an asymptote. All right, and if you look at where the 100 is, in this case it's actually is the y-intercept as well. Okay, we'll do a bit more of these tomorrow, just so you guys get to play around, because I'm more interested in doing like the negative ones, and then I'll show you guys what the reflection looks like on x-axis and y-axis. Cool. Cheers, guys.